Hi everyone. Today we're going to continue to build off of what we had been working on last class, which was this idea of how do we communicate information when there's really only two states of being for a device. So I want to start off by asking everybody to consider how many different ways you can represent 7. And if you are watching, if you were absent, or if you lost any kind of connection when we were doing this in a synchronous way and you're doing this at home by yourself, I want you to hit pause on this video right now, take a moment, and on a piece of paper write down all the different ways 7 can be represented. Okay. And so in discussing the different ways that 7 can be represented, we have the idea that it can be represented linguistically, right? You can say 7, sept, you could German, French, whatever it is. You can have pictures, you could have dots and tallies, emojis, 7 different colors, 7 crayons, anything like that. And then you also have math and geometry. You could have a 7-sided shape, you can have 5 plus 2, you can have 8 minus 1. So there's a lot of ways to represent the number 7. And so why are we even talking about 7? We could be talking about any number when we're having this discussion, but the reason for understanding this is really understanding that it's kind of arbitrary. And we're used to the shape that looks like this, and it means something to us, but it's a pretty arbitrary shape. There's nothing about this line on the top that's horizontal and then this diagonal line coming down that really means 7 other than it's our experience that it does. And in thinking about the fact that there are different ways to represent numbers, I want you to imagine that you have in front of you circles and squares, and you have 3 place values, 3 boxes across. And I want you to tell me how many different combinations you can make with circles and squares with 3 place values. So some of the patterns might be circle, 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 maybe circle, square, circle, etc., etc. So spend some time on that. Hit pause, please, for a minute or two until you figure out how many patterns, different patterns you can make using circles and squares if you have 3 place values. Hit pause, go do that, and come back. Okay. Assuming that you really hit pause, you will know that there's 8 possible patterns. We're not going to list them all out here, but everyone can just kind of check and make sure that you have 8 possible patterns. Okay, so not everyone wrote the patterns in the same order, I'm sure. So if we had 6 different groups of kids partnerships working on this, not everyone's going to write them in the same order, which means we don't all have the same. If I asked you all to tell me, okay, what's your 7th pattern down this list? Not everyone would have the same 7th pattern. So what we're going to try and accomplish during this lesson is we want to create a clear set of rules where if the class were to follow the rules, remember we're going back to the protocols, everyone should generate the same list of patterns in the same order. So let's see if we can move along over here. Okay, and all right, so because this is virtual, again, in the real world, I'd be handing you little circles and little squares, and you'd be working this out with these manipulatives on a desk with a partner, but we can't do that. So instead, I'm going to share with you this interactive slide. So as you can see in this interactive slide, you're going to record, I'm just going to read through the instructions. You're going to record all the possible 3 place value patterns that use the circle and square shapes. Some examples are in the diagram to the right. Try to make these try to make sure these patterns are in some type of order and avoid putting down patterns randomly. So you're going to almost make the rules first, the same way you did when we had the devices in the last class. Your challenge 2, you're going to describe your rules. Reflect on how you put the patterns below in order from one line to the next. Are there any clear rules to follow? If you didn't have clear rules, redo challenge 1 with some rules in mind. Okay? Okay. So this is group 1. Okay, so I'm not sure why we have the same. Let me just, so I have 2 of the same slides. Okay, so the next challenge is going to be use your rules from the last page to try and generate all possible 4 place value patterns using only circles and squares. 3 examples are listed to the right. You may need to add new rules or slightly change the rules to account for all 4 place value patterns, but try to keep them as similar as possible. Now, if your rules can be used well in another group, right? You come up with rules and another group was able to follow your rules and write out different patterns, then you have pretty much achieved your goal, right? So here in this example, maybe it's a rule that 2 circles, that every square represents 1 and every circle represents 0. And maybe this is the ones place, maybe this is the tens place, maybe this is the hundredths place. That sounds really familiar to what we know, but there are a million different ways you can think about this. But if this is the ones place and you only have 2 shapes, could this be the tens place? Because, for instance, this would represent, and this represents a 1, and this represents a 0. So this would, when you add these all up, this would equal 1. But what would you have for 2? If you put a square here, well, this is worth a 10, and this is a 1. That would be 11. So how does this work if you only have 2 possible states or 2 possible shapes? So think about that. All right. So assuming we're really thinking about number systems and we're thinking about base 2, base 10, base 3, I hope that you've realized that when you change to, I'm going to go back to this, when you change to the next place value, it can only change by 2. And we will talk more about this when we talk about binary, which is where we're going with all of these different things, okay? So just in closing, I want to congratulate you if it worked, and I want to tell you that you invented your own counting system, and you have lots of different ways to represent numbers, right? And we need to really think about this. This is what happens a lot as new technology is invented and fine-tuned. Different technologies might count in different ways. And tomorrow we're going to learn about the counting system computers used to represent numbers, which is binary, right? Okay, so what I'd like you to do as a follow-up is answer any questions in Code Studio and have that done for the next class. All right, thanks very much.